Myself Dr. Dushan Pradeep and you're watching physics classes by Dr. Dushan. Please share and subscribe this YouTube channel so that we can have a good number of. So let's start with the topic. Today's topic is an extension to our previous lecture on the lasers, and today we are going to discuss the types of laser. In our previous lectures, what we have done, we have discussed how laser are going to function depending upon the three essential part of the laser. So यहाँ पे हम डिस्कस करेंगे कि अकॉर्डिंग टू देयर सोर्सेज हमारे पास टाइप्स ऑफ लेजर्स कौन सी हैं. लेट्स डिस्कस फर्स्ट वन, दैट इज द डिफरेंट टाइप्स ऑफ लेजर based upon what their sources. So what we are having here, first one is gas laser, second one is crystal laser, third one is semiconductor laser, fourth one is liquid laser. So कि आपका मीडियम, आपका सोर्स कैसा है, आपके पास गैस हो सकती है, क्रिस्टल लेजर्स हो सकते हैं, सेमीकंडक्टर मटेरियल पे हो सकता है, या लिक्विड्स, वट एवर यू आर हैविंग योर लेजिंग मीडियम. नेक्स्ट वन, एमिशन कैसी हो रही है. एमिशन आपकी रेगुलर एमिशन है या स्पाइक्स में हो रही है या स्मॉल पल्सेस में हो रही है. वी आर हैविंग टू टाइप्स ऑफ लेजर. वन इज कंटिन्यूस जिसमें हमारे पास रेगुलर एमिशन होगी, द अदर वन इज पल्स्ड लेजर. पल्स में क्या होता है, स्मॉल पल्सेस आउट आती हैं और हमारे पास एक जगह पे एक पॉइंट ऑफ टाइम पे हमारे पास स्पाइक्स आती हैं, वेरी हाईली इंटेंस बीम ऑफ लेजर. और नेक्स्ट डिस्ट्रीब्यूशन डिस्टिंग्विश ऑन देयर वेवलेंथ्स. विजिबल रीजन, विजिबल रीजन में लेजर जो हमें विजिबल होंगे ऑन बेस्ड अपॉन डिफरेंट कलर्स. इंफ्रारेड, दे आर नॉट विजिबल. ultraviolet, they are higher energy as compared to infrared. Microwave region and the X-ray region, the highly intensified energy as well as the beam of lasers. So according to the different levels, how many levels are there corresponding to the ground state, excited state and metastable state? If the laser has only two states, means your ground and excited, they are two level laser. If you are having one more level, that is metastable, means आपके पास तीन लेवल्स हैं. नंबर एक आपका ग्राउंड स्टेट, नंबर दो आपका एक्साइटेड स्टेट, और तीसरा यहां से जंप करने पे लेजिंग एक्शन होगा, वो होगा आपका मेटास्टेबल स्टेट. एंड द थर्ड वन इज योर मेटास्टेबल स्टेट फ्रॉम विच व्हेन द इलेक्ट्रॉन और एटम इज गोइंग टू जंप to the ground state, the lasing is going to take place. And the last one is your four level laser. We are having two metastable states here. According to the mode of pumping, how pumping is taking place, we have already discussed this. One is optical pumping, in which the source of pumping energy is light. Chemical, with the chemical reaction excites the electron from lower energy state to higher energy state. Third one is your electric discharge, in which the ionization process can increase the energy from lower energy state to higher energy state. And the last one is the electrical. इस electrical state में हमारे पास क्या है, लोअर एनर्जी स्टेट से हायर एनर्जी स्टेट में इलेक्ट्रॉन जाते हैं विद द हेल्प ऑफ एक्सटर्नल इलेक्ट्रिकल पोटेंशियल हियर. आई थिंक यू माइट हैव गॉट सम आइडियाज अबाउट द टाइप्स ऑफ लेजर. सो हियर व्हाट वी आर गोइंग टू हैव हियर, टू लेवल लेजर. इन टू लेवल लेजर वी आर ओनली हैविंग अ ग्राउंड स्टेट and an excited state. The electrons have a stimulated absorption, then they take the emission here. Now it is clear from these diagrams. The electrons are getting excited from E1 to E2 level, and after spontaneous emission, the electron comes down to E1 level. So here, if it is stimulated emission, two photons which are coherent, which are having same wavelength, same direction, they are coming out from this. This is two level laser. And the next one is three level laser. We are having stimulated absorption, spontaneous emission to the metastable state, and then stipulated emission from meta to ground state. तो हमारे पास तीन states हैं. E0 जो हमारी ground state है, फिर यहाँ पे इलेक्ट्रॉन है, वो कहाँ से कहाँ मूव करता है, E2 एनर्जी स्टेट पे. E2 एनर्जी स्टेट हमारी एक्साइटेड स्टेट है, और फिर E1 जो हमारी क्या है, मेटास्टेबल स्टेट. जब इलेक्ट्रॉन E1 से E0 पे आएगा, तब हमारे पास क्या होगा, लेजिंग एक्शन होगा. देखिए अब हमारा इलेक्ट्रॉन कहां से जा रहा है, E0 से चला गया E2 पे. At E2 it is having a higher energy, and from here it is spontaneously emitted to the metastable state. Metastable state पे jump करता है after spontaneous emission, after completing its journey lifetime, and at metastable state it resides for more time, and there is a place, that is the place where there is going to be a population inversion. So population inversion is going to take place. So number of electrons, that density of electron builds here at the E1 energy state level. Now when this jumps back to the E0 state, there is a lasing action and the electron. This is the population inversion 3-state laser. This is the complete diagram. Here what is happening here, you can have the watch on it. So this is happening in a 4-state level. We are having 2 metastates, is the level 3 and level 2 are going to represent this, and we are having this level state. So practical laser, what we are having here, we are having the ruby laser. The construction that you are having a complete diagram on it. So there is a ruby laser. In ruby laser, what we are having aluminum and chromium. So aluminum oxide Al2O3, that is having, and there is a mixture of Cr plus, there is a doping in it, and that is increasing the number of electrons which are excited there. We are having different transitions which are taking place here, and at the last one we are having a lasing. They are represented by here the rapid decay, that is a random decay of the particles from one state to another, and we are having, this is your energy level in the ruby laser. Ruby laser is what? You might have got the idea that Al2O3 has a addition of what? The impurity Cr plus ion. So next देखिए यहाँ पे आपके पास एक एनर्जी डायग्राम है और एक एब्जॉर्प्शन आपके पास क्राइटेरिया दिया गया है कि डिपेंडिंग अपॉन डिफरेंट वेवलेंथ, ब्लू में है, ग्रीन में है, यू आर हैविंग फॉर व्हाट? Cr3 प्लस रूबी लेजर, ठीक है। और नेक्स्ट में आपके पास ये एनर्जी लेवल बता दिया कि यहाँ पे आपके पास एक फोटोन एमिट हो रहा है। फोटोन की एनर्जी कितनी है, वेवलेंथ कितनी है? 694.3 nanometer, and that is the ground state energy. And the next one is the case in which we are having an helium-neon laser. In the helium-neon, the construction is very much displayed here in the diagram. What we are having in Bristol window is there, anode is represented, and with the cathode both are what? Both are attached to a power supply, and we are having 2 resonators here. Resonators are what? A completely partially plated your resonating mirrors over there. Now this is the energy level diagram of helium-neon. Helium-neon is a gas laser in which there is an emission of a wavelength 6328 angstrom due to the emission of helium and neon at higher energy levels. Helium-neon energy exchange due to the collisions. ठीक है, यहाँ पे क्या होता है? Collisions होते हैं. If still you are not having, we can discuss complete helium-neon and ruby laser on next lecture. Electrons के helium-neon के collisions होते हैं. Electrons move करते हैं helium from this energy level to this one. ये कौन सी है आपकी? 1s0. ये 3s2 metastable state पे चले जाते हैं, और यहाँ पे आपके पास एक emission होता है जिसमें आपके lasing action होता है, जिसमें एंगस्ट्रॉम है 6328 एंगस्ट्रॉम का लेजर बीम बाहर निकलता है। उसके बाद एक रैपिड डी एक्साइटेशन होती है और नियॉन जो है वापस अपनी ओरिजिनल ग्राउंड स्टेट में आ जाता है। ये था एनर्जी लेवल डायग्राम हीलियम नियॉन का, जहाँ पे आपके पास एमिशन हो रही है 3s2 में और 2p4 में। This is a combined lasing action. Electrons are getting excited from 1s1 to the 1s2 second energy state. After collisions, helium और neon, हीलियम अपनी एनर्जी पास करता है नियॉन में, और यहाँ पे कुछ एमिशंस होती हैं 3391 नैनोमीटर की भी होती है, बट वो स्पॉन्टेनियस है, बड़ी कम है, उसका लेजिंग एक्शन, लेजिंग बीम इतना इंटेंस नहीं है। सो वी आर हैविंग एन इंटेंस लेजर बीम ऑफ व्हाट? 6328 एंगस्ट्रॉम. This is what we have discussed about this. So emission wavelengths of the common laser. This is the list of the wavelengths for such as the laser on the argon fluoride, krypton, xenon, nitrogen, argon, helium-neon, red and green, both the wavelengths, and ruby, neodymium YAG, ND-YAG, that is one of the best laser here, and the carbon dioxide here. Now, what are the applications? Applications are very common. The lasers are now being used in a different applications of what? What we are having. One is communication. Next one is the surgery. Long distance measurement के लिए use होता है. Then for the nuclear fusion, साइंटिफिक रिसर्चेस के लिए यूज होता है, इंडस्ट्रीज में यूज किया जाता है, एंड मोस्टली फॉर कटिंग डिफरेंट मेटल्स, and in the defense, both for the defense, for the detection of certain material, detection of certain places and distances of certain arms which are coming through the defense state. So that is the most common list of the applications of the lasers. And but we are having the application in a particular diagram. The medical optical surgery is there, journal surgery and tattoo removal is there, entertainment, CD players, DVD players, video game systems, information technology, holograms are there, satellites they are working on with the help of the lasering technology. In military we can use them as weapons or radars. Oh, that was all about the laser. I think you might have noticed certain things, that what we are having, the dentist use, a dentist while checking your teeth, they are using a laser drill here. The bad eyesight can be corrected, optical surgery using laser. We are having a CD audio read by a laser. We are having a tattoo removal done using the laser. These are the list, actually diagrammatical representation of the applications. Laser pointers can enhance the presentation, and barcodes these days, the grocery items are scanned by the lasers, and video game systems. These are all what we are having in our applications. You can have a great number of applications here. Laser technology used in printer, copiers and scanners these days. So thank you very much. That was all about your today's lectures. That was the lecture, a complete series on the lasers. Thank you very much. Please share and subscribe this YouTube channel, Physics Classes by Dr. Dishant. Have a great time ahead.